Hi team, Mr. Ratoya, revisiting the discriminant. Let's look at this question. So it's a bit of a tough one at first. Well, it looks pretty tough, and then when you break it down, hopefully it'll make a bit more sense what's going on. So it says here, find a condition of M in terms of A and C so that this line is tangent to that. Right, before we do anything, well, if it's tangent, it's going to be touching, it's going to be hitting it at once and then shooting off. So let's just equate this at the moment. Let's just say mx plus c is equal to a over x. So what I can do now is I've equated this straight line with this reciprocal graph, so we equated them. I want to get rid of the fraction, okay, always trying to get rid of the denominator. So what we can do is just times everything by x. So times every element by x, and we end up with mx squared plus cx equals and that x times this disappears, so it ends up with a. Now bring that all to one side, so we end up with getting mx squared plus cx minus a equals 0. Now once we've got it in this form, because it's 0, this is a quadratic equation. Now quadratic equation in this case is important because when we know that we just want the M in terms of A and C where this line is tangent, and if it's tangent it means it only has one point, and if it has one point that tells us that the discriminant b squared minus 4ac must equal 0. Okay, so this is always the case when there's one root for a tangent. Okay, so as there is only one solution. Okay, so this happens in the case of the tangent. So straight away we can say A is equal to M. Sorry, this A is different to that, so don't confuse it. I'm using the quadratic A coefficient, A of x squared. B is equal to, again, don't get confused, this is C in this case. And the C in this case is minus A. Okay, so just be careful. The A, B, C in this form is for the quadratic equation when we have it as ax squared plus bx plus c equals 0. So just be careful. We don't get confused with that. So apologies for that. It's just got to be extra careful when you're dealing with sometimes something like this when the letters are the same. So let's plug it in here. So in this case, the b squared is c. So we can say that's going to be c squared minus, this was 4ac by the way, 4 in this case is 4a is m, and c in this case is minus a, which is going to equal to 0 for the tangent. So to find this out, we'll end up getting c squared. Two negatives make a positive, so we end up with 4am equals 0. Now we want m in terms of a and c, so I'm going to take the c squared to the other side, so I'm going to end up with 4am equals minus c squared. I'm going to just want m by itself, so I need to get rid of 4a by dividing it to the other side because it's been multiplied here, so that ends up being c minus c squared over 4a. And that's it. Okay. Right. Now it goes here for this one. The function f of x is a cubic. So remember, cubic can either look positive or going down as negative. Show graphically the curve y equals, so that's a reciprocal graph, can intersect the curve at 0, 1, 2, 3, or 4 places. So let's just, well, 0, straightforward. If we sketch the graph here, let's just do the reciprocal graph. This is the graph. Okay, so this is this graph. Do this graph in red, and I do the cubic graph in blue. Okay, so now no solution, so very straightforward. We can just do a negative graph going like that, so there's no solutions there. So 0 solutions. They don't intersect. Okay, let's look for another one. Okay, and if I could draw that axis in purple this time. So again, the red graph, just a reciprocal graph. So we want one solution. We can just say cubic graph, any, just go up, come down, just do stand. So this could be anything going up, down, and then back up again. Okay, so there's only one solution there. So one solution. Cannot spell. One solution. Okay, let's have a go at another one. So let's have a go at the 2. A bit smaller so we can fit them all in. Again, let's just do the reciprocal graph like this. So we want 2 solutions. What we could do here, again, we could just come up with a graph going up and through there and then down. Okay, let's try that one. So could say this graph could come going up this way and then bend and then go back up. So we've got 2 solutions here. So 2 solutions. Okay, so cross is there, cross there, it makes a bend and then goes back up. Okay, we'll go for the graph with 3 solutions, and then we go for one with the 4. So again, let's just do the reciprocal graph going like that. So 3 solutions, we go 1, 2, 3. Yeah, we could just do it on one side, so it doesn't even go the other side. So it just goes graph going up, down, and back up again. Crosses this 1, 2, 3 times. This has 3 solutions. Okay, 1 there, 2 there, 3 there. This is got 1 there. It's got 1 here, and 1 here, so 2 there. Okay. So any type of graph would do, as long as the curves look the same, similar shape, and it doesn't really matter whereabouts you plot them, left or right. Many examples. So obviously infinite examples of these. It goes up here, it's going down. 4 could go 1, 2, 3, 4. Yeah, let's do that. So this time, to get the 4th one out, it's very similar to this, but this time we're going to cross it from here. 1, 2, 3, 4. We'll have something like that. So we've got 1 here, 2 here, 3 here, 4. 4 solutions. So 4 intersections, 4 solutions will make it. So here are examples of how you could show this graphically, those 2 curves having that. Okay.